This is experiment 1 with charged tapes. The purpose of this experiment is to estimate the charge of tape through observations of interactions between the two pieces of tape and their surroundings, and it is also to determine the excess charges on an object. The results of this experiment as an overview are that the tapes have the same positive charge of approximately 1.14 times 10 to the negative 8th power coulombs. The deficient electrons were found to be 7.1 times 10 to the 10th power, and then the ratio of electrons to atoms is 1 to 5.09 times 10 to the 7th power. Some of the fundamental concepts include gravitational force, knowing Newton's second law, which is that any net force on an object will result in acceleration, and an object at rest or moving with a constant velocity must have a net force equal to 0. Additionally, Coulomb's law, which states that electric force is equal to Coulomb constant times charge 1 times charge 2 over the distance between the two charges. And you use 9 times 10 to the 9th power for the Coulomb constant. The system in question for this experiment included the charged tapes and the charged pen, and the surroundings for this experiment were the neutral table, the books, and the books that the tapes were placed on. The assumptions made about this experiment were that the charged tapes can be treated like point charges, where the charge is concentrated at the center, and that both tapes have the same charge. To do this experiment, the base tape was applied to the table, and then two tapes were measured out, and the ends were folded down as handles, so these were the charged tapes, and you can see that in the diagram on this slide. The charged tapes were applied to the base tape and the other objects, so the other objects included the other tape or the plastic pen that we charged negatively with by rubbing it against your hair or your clothing. Both tapes were charged, and then one was hung between two books, and then the second charged tape was brought closer until the tape floated. So this was the point at which electric force was equal to gravitational force. Some of the observations made were that the charged tapes repelled one another when they were brought together. This would mean that they have the same charge. The tapes are also positively charged, and we know this because the tape was attracted to the negatively charged pen. The tape also began to float at approximately 2.5 centimeters away from the other tape. So to do the calculations, we knew that Scotch tape has a mass of 1 gram per meter approximately, and then that means that the 19 centimeter tape times 1 gram would be 0.19 grams. So the force due to gravity was found to be 1.86 times 10 to the negative third, which assumed that the vertical forces of the books on tape were negligible as it floated. And then we set the gravitational force equal to kq squared over r squared and solved for q. Q was found to be 1.14 times 10 to the negative 8th power. And then to find the number of deficient electrons, you just divide the charge Q by the electrons. So that was equal to 7.1 times 10 to the 10th power. So that's the number of deficient electrons. And then the surface area of the tape times 1 times 10 to the 20th power was equal to the number of atoms. So this calculation was done by dividing 0.0036 by 1 times 10 to the 20th power, and we got 3.61 times 10 to the 17th atoms total. And so the number of deficient electrons over the number of atoms is equal to 5.9 times 10 to the 7th power. This is my glow script representation. All the fixed variables are set up top, including the observed ones, such as distance between tapes when they begin to float. And the two forces were created, gravity and electric force, which are equal in magnitude. Two particles were created. These were represented by spheres. These are representative of the charged tapes, so the point charges of the charged tapes. And then the calculations done earlier were included in the code, and you can see the outcomes of those beneath the visual representation. And this is more like a free body diagram, and you can see the code on the right. If the electrons had a positive charge and protons had a negative charge, my observations would be the same. And then, why is it important to handle charged tapes as little as possible? Because our hands absorb some of the charge, which would affect the results of the experiment as it changes the amount of charge in the tapes. And we are trying to calculate the charges in the tapes.